rationalize the numerator, then simplify your answer. In part A, the numerator has radicals, is square root of 3 plus square root of 5. So the purpose of rationalizing means making it a rational number, right? So as a plus means we multiply top and bottom by minus. If this is minus, if this were minus, then we will multiply by same thing but plus. So in part A, so we write the given number, then multiply by the conjugate of this one, because we are asked to work with numerator. I mean, anyways, in this fraction, the bottom is already a rational number, so this one is irrational. So we multiply by conjugate means the middle here. Okay, so root 3 minus root 5, and we have to have the same thing on the bottom, root 3 minus root 5. Okay, so basically we are multiplying by 1, which is always allowed. Now, so we don't have to worry about the bottom because we are only working with the top. So 4 times this, the plus minus means it's a single factor, so we put parentheses around root 3 minus root 5. Okay, this is one block. Now we multiply the top. The root 3 plus 5, root 5, root 3 minus root 5. This is pretty much the difference of two squares. So when we know that when we have a square minus b square, this one factors is a plus b, a minus b. That means if we multiply these two, we get back this. A plus b times same thing but minus, and when we multiply, the middle two terms cancel, only a times a square minus last b square. So every single time when we rationalize, we have that situation, because if this is plus, we multiply by minus. If this were minus, we would multiply by plus. So every single time we will have this situation. We can FOIL and cancel middle two terms, same thing, but this one is shorter. So root 3 times root 3, root 3 squared, so that's 3. Minus, the middle two terms cancel, don't have to bother. So last, root 5 times root 5 is 5. Root 5 is squared, which is 5. And 3 minus 5, because we can subtract, negative 2 over 4 times root 3 minus root 5. By the way, we cannot subtract or add, okay? We cannot add or subtract because these are unlike terms. But 2 is factor, 4 is also factor, so 2 goes once, 2 goes twice, and we have the final answer. Negative, we can pull to the front, 1 on the top, there is a 2 times quantity root 3 minus root 5. Okay. Now let's do part B. So we're going to use the same thing again here, like a plus b times a minus b, or a minus b times a plus b is always a difference of two squares. Okay, so in part B, so we are concerned with the top, right, numerator. Then we multiply, so don't bother with the bottom, just the top. So this one is 1, and another 2 terms, there is a minus in the middle, not this one. Okay, this one between 2 different terms. So this will be plus, and copy the same thing. Root x times plus, root x plus h. Now we need to write the same thing on the bottom. Root x plus h. So essentially we are multiplying this by 1. Writing same thing top and bottom means multiplying by 1. That's illegal. So let me make room for this question. Now our concern is for the numerator, so we just leave bottom as it is. We have h root x plus h, and then this plus means we need to put parentheses around root x plus root x plus h. On the top, it's like a minus b, and this one is a plus b. If we multiply, that's the difference of two squares. That means root x times root x is squared, which is x, and root x plus h is root x plus h is squared. That means x plus h minus, okay, in the middle, x plus h. But because of this minus, we need to distribute, or we need to put parentheses around. Okay, you must put parentheses around. I will just distribute that negative sign so that we can skip one step. This minus makes this plus also minus. This is x plus h, and then distribute this minus, that makes minus. Okay, on the top now, x minus x, we can cancel here. Minus h survives. Minus, we can put in the front h over everything on the bottom. H root x plus h, root x plus h. And by the way, h and h also cancel now. That means nothing means 1, okay? We are dividing by 1. So the final answer is whatever we have there, negative 1 over root x plus h, root x plus h, final.